Okay, so today we're going to deal with a very, very simple topic. Um, you'll see the textbooks. This is what they call it: factor and remainder theorem, right? It's really one theorem. There's sometimes you see some books say the remainder theorem. Some people say the factor theorem. Some writers they say, look, let me just put the two together, factor and remainder theorem. And let me explain how simple this is. Like, okay, if I take a number, let's say, all right, 6, right? And I divide it by one of its factors, 3. What do you get? You get 2 remainder 0. That's all. Hmm?
Yeah, the
Yeah. Let's say you take a number like 7, you divide by 3 now. You'll get 2 remainder 1, right? So,
yes,
so
sir.
you can write, okay, 6 is equals to 3 multiplied by 2. Down here, 7 is equals to 3 multiplied by 2 plus 1, right? Well, all we're going to do here now is apply this same idea, right, um, to algebraic expressions now. So let me give you an example of what I'm talking about. Let's say you take the expression, you got this function, fx equal to x squared plus x minus 6, right? I want you to notice something that, okay, all right, if you I'm going to factorize it, right? I'm not going to show you the steps and so, right? I'm just going to write down the factors, right? So when you factorize this here, you get this, right? In other words, if you were to divide this expression by x minus 2, you should get x plus 3. Similarly, if you were to divide this expression by x plus 3, you're supposed to get x minus 2, right? Just like you were doing with these pure numbers here. Good. So let's try that division and see what happens, right? And I want you to pay attention to a bit of division here, right? Um, so let's do the division. We're dividing, what is it? X squared plus x minus 6, and we're dividing, all right, let's divide by x minus 2. X minus 2, right? So this is what you do. You divide x squared, this here, by this x. You get x. And next you multiply. X by x, you get x squared. Minus 2 by x, you get minus 2x, right? And let's say you subtract here now. So the x squares are going to go, right? X minus minus 2x, you get 3x, right? You can bring down the minus 6. Is now you do long division, you call it. So then you go x into 3x, you get 3, right? X by 3, you get 3x. Minus 2 by positive 3, you get minus 6. And if I were to subtract here, look at what happens, right? So indeed, you see that when we divide x squared plus x minus 6 by x minus 2, right? Your dividend is x plus 3. And your remainder, usually here is where you see the remainder, is 0. So indeed, x minus 2 is a factor of x squared plus x minus 6, right? And similarly, if I'm to do it the other way, let me just do it for the sake of um, at least you'll see another division, you know, and you'll see how it's done and so again. So this is how you do it, right? Write this thing. I forgot how to write this thing now. So I'm going to divide by x plus 3. X plus 3, right? So x into x squared, you get x. Okay. X times x, you get x squared. 3 times x, you get 3x. Okay. All right. Your subtraction. You'll get down here minus 2x. Bring down your minus 6. All right. X into minus 2x, you get minus 2. X times minus 2, you get minus 2x. 3 times minus 2, you get minus 6. So when you subtract, you get 0. So indeed, x plus 3 is a factor. When you divide x squared plus x minus 6 by x plus 3, you get x minus 2. Right? See that? So
Yes, sir. Yes, sir.
yeah. So now look at something else now. So you're getting used to this division, eh? Let's go back. Let's take back the same R. You want me to leave it there for a little? Anybody's watching the whole thing?
Yes, sir.
All right, good. So somebody figure out this now. So we have, okay, what is it? We had x squared fx equal x squared plus x minus 6, right? And when we factorize it, we have what? X plus 3, x minus 2, huh? All right, good. I want you to watch something now. What's something? If I were to find f2, that would be equal to 2 squared plus 2 minus 6, which is 0, right? Similarly, if I were to find f minus 3, I'll have minus 3 squared minus 3 minus 6, which is 0. You notice that? When we take the number in here, right, the opposite sign, put it in the function, we get 0, right? And somebody we came up with the idea then, and hey, you know what? I could make a little rule, right? So basically, we're saying that if you have a function, um, if you have a function fx and f of a is equals to 0, then x minus a is a factor of f of x. See if that is not true. So if you have a function and you put in a number a, and the function works out to give you 0, then x minus a is a factor of the function. And that's what's happening up here, right? We're seeing that when we put 2 inside, it works out to give you 0. Therefore, x minus 2 is a factor. Down here, f minus 3 gives you 0. Therefore, x plus 3 is a factor, which you see, right? And this is a very basic way of writing the factor theorem, right? Of writing the factor theorem. There is a more general way. Maybe I can illustrate that with probably an example or so. Give me a second. Anybody writing this? I can move it, maybe.
Yes, sir.
All right.
I finished writing it.
All right. It's recorded too. You can always watch it back. But it's good, as I said, right? It's good if you take notes, right? Um, it does a lot for you, and sometimes it slows me up as well because when I don't know if you're taking notes, if you're there, but if you say, "Hold it, sir, I wanna I'm writing that thing," and so on, as I told you before, using your hand to make notes, handwriting, right, is so beneficial to your brain. I spoke about memory and you're being able to summarize and what somebody is saying and put it in your own words. All of that is developing a lot of, what I said, cognitive processes, right? So that's a very good thing. Have a notebook. Don't just sit down passively and maybe the TV is on and we're having a video game. And for the older folks, I guess them teachers must be cooking and whatever else they do. All right. It's
Yes, sir.
not going to, it's not going to work, right? It's not going to work. I really feel during the orientation, I needed days to sit with y'all and walk through so many things about UG, right? Well, at the end of this lesson, I'll talk a little more when I talk about your test and all of that. Good. Look at another one. Where am I? So look at this one. So let's say you have this function. You have a function, all right? 3x squared minus x minus 2. Right? I'm going to factorize it as well. This function is factorized to give you this by 3x plus 2, right? Factorize there, it's equal to that, right? Good. So I'm going to use this here. I'm going to use this here. And so now you realize that this here is even more difficult to do your division now, right? It's difficult to do your division. So if you were to divide, all right, this function by this here, you get x minus 1. Now, if I were to try f, what would this be? F, would it be minus 2 over 3? Right, let's see what we'll get. You get 3 times minus 2 over 3 square minus 2 over 3 minus 2. And you should get 0, right? If you check it. What you'll get? You'll get 4 over 9, all right, plus 2 over 3 minus 2. It should be easy. It should give you 0 because this 3, okay, right? And if you were to add these two, you will get what? 6 over 3, which is 2, right? Indeed, it is 0, right? Good. So there's a more general form of writing the factor theorem, right? And this is how you can say it. If f of x how did I write this one? Okay, all right. If f of x is a function, all right, I'm gonna maintain my the structure like the one before. And f of b over a equals 0, then ax plus b uh, should be I'll go with the minus. 1 second. Is this thing doing anyway? Right? So what they're saying here is just that if you have a factor looking like this, right? See, it's a more general form of writing the factor theorem. So if f of b over a is equal to 0, then ax minus b is a factor of f of x. And we see that with this, right? We see that with that. We got a function 3x squared minus x minus 2. That's this function here. You factorize it, you get this. And indeed, when you put minus 2 over 3, x equal that, look at what happens. You end up with 0, right? Which tells you that 3x plus 2 is a factor. This is one way of writing it, right? Let me talk about the remainder a little, and then I'll try to combine it into one, right? I'll try to combine it into one. So let's deal with a situation when you have a remainder. I'm looking for a good example. All right, let's deal with one when you have a remainder. So I'm going to use the very first one we see here. Is a simple one. Yeah, these very difficult ones. All right, let me go back to the very first one we had. What do we have? Fx is equal to x squared plus x minus 6, right? And let's just say, all right, we want to divide this by x plus 1, right? X plus 1. So let's do the long division. See what happens. I did that the wrong place, sorry. Let me do it here. Got x squared plus x minus 6 divided by, okay, x plus 1. Let's see what happens. X squared divided by x, you get x, all right. X by x, you get x squared, okay. 1 by x, you get x, okay. Well, let's see what happens. You subtract, that goes, okay, this goes too, and you're left with minus 6. Right? So basically what they're saying here is that makes a lot of sense, that x squared plus x minus 6 is equals to x times x plus 1 minus 6, right? And that makes sense. It is true, right? 6 is the remainder then. 6 is the remainder when you divide x squared plus x minus 6 by x plus 1. I should have used maybe another number here, maybe x plus 2, and see what happens. Yeah, let me try that. All right, we can work with this. But notice something now, right? When we divide x squared plus x minus 6 by x plus 1, we get minus 6. Look at this now. Let me try f of minus 1, right? I'm taking the opposite sign here. F of minus 1 will be equal to minus 1 squared minus 1 minus 6, right? Oh, what am I doing? Minus 1. what do we get? We get minus 6. See that? So we can actually find the remainder without having to do this long division too. You see? So with the factor theorem, we can know if it's a factor, but we can also find the remainder, right? We don't have to do this long division. We don't have to do that long division. We can actually find the remainder using what we later on referred to as the factor the remainder theorem, right? Let me show you. Take the same function. Let's go with dividing it by x plus 2. See what happens. So x into x squared, you get x. X by x, you get x squared. 2 by x, you get 2x, okay? And you subtract, right? Subtract here. So the x squares will go and you end up with minus x minus 6, all right? X into minus x is minus 1, right? X by minus 1, you get minus x. 2 by minus 1 gives you minus 2. Subtract now, and we get minus 6 plus 2 give us minus 4. So what we're seeing here is that when we divide x squared plus x minus 6, we're getting, if we divide by x plus 2, we're getting x minus 1 minus 4, right? And indeed, if we were to expand this out and minus 4 from it, we'll get back this. So what we see also here, when we divide this by x plus 2, we get a remainder of minus 4. Let's try this. F minus 2, right? I'm using the opposite sign here. So look at what happens. You get minus 2 square minus 2 minus 6. So let's see what we get. So this will be 4. 4 minus 2 is 2. 2 minus 4 is minus 4. So you see, you don't have to do this long division. You can actually find the remainder by simply putting in minus 2, the opposite of this here. Put in minus 2 in there, and here is your remainder. Right? And that's why I think I'm gonna fetch the statement in the notes I'm sending to you. And this is how they state it in the notes. If fx is any polynomial, they didn't call it a function, they call it a polynomial. And fx is divided by x minus a, then the remainder is fa, right? From this, if fa is, or okay, let me put it, equals 0. If fa equals 0, then x minus a is a factor of fx. All right? I'm just adding on the factor theorem at the end here, right? Really and truly, the factor theorem is implied here, right? It's implied. It's not, you don't have to say everything. By saying that if fx is divided by x minus a, the remainder is fa, by implication, without saying it, right? it is true that if a equals 0, because this is the remainder, if the remainder is 0, then x minus a is a factor of fx. That's how the notes that I sent to you there puts it. I'm going to put it more generally now. I think they actually did it in the notes. On the second page, they actually added on. How do I do this? Oh my, what happened here? Got virus take over my so this is how the notes this is how it's stated more generally. If fx is a polynomial and fx is divided by ax plus b, I think I use ax minus b, doesn't matter. Then the remainder is f of minus b over a. If you use a minus sign here, there's no need for a minus sign here, right? I guess you should get used to that switching around, right? So if you divide fx by ax plus b, the remainder is f of minus b over a, right? And if f of minus b over a is equal to 0, then ax plus b is a factor. So this captures the whole thing now, right? In one statement, right? So, and this author called it just the remainder theorem. Some textbooks you'll see it as the factor and remainder theorem. I guess this author is saying the remainder theorem is actually implied, right? But indeed, he put it like this. Think you're following anything so far? Anything making sense?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Or what about if now? What about if you have something as ugly as this now? What do you say? Let us just see, right? Let us just say give me a second. I'm looking for a nice one that one second. I want one that will put your brain to all right, look at this one now. Let's say you're told to factorize something like this now. X cubed plus 2x squared minus x minus 2. You have to factorize something like that, right? How do you do something like that? Well, you have to hunt around now. You have to start figuring out, I need to figure out a factor of this expression here, right? So I'll give you a little clue. Think of factors of minus 2. And when you think of factors, don't only think about the negatives, right? Think about the positives. Think about the negatives as well. So they got -2, they got -1, then 1, then 2, right? So think of these numbers here. Let's try them. Let's try, all right, f of 2. Let's just try that. So we'll get what? 2 cube plus 2 times 2 square minus 2 minus 2. Will that be 0? Yeah, this, no, it's not going to give you 0. No. But what if we go, this is not going to be 0, right? It's not going to be 0. Because this is 8 and that's another 8, right? So no, that can't work. What about we try minus 2 now? We'll get minus 2 cube plus 2 times minus 2 square, right? Plus 2 minus 2, right? Will that be 0? So this is minus 8. No, that doesn't sound right. Minus 2 cube will be minus 8. And this will be positive 8. Yes, 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 yes. And this is going to be 0, right? See if you agree with me there.
Yes, sir. Yes, sir. B0.
Good.
Yes, sir.
So
I was a little
therefore,
but the plus, but then I realized, oh,
yeah,
the x is negative.
x plus 2 is a factor, right? X
Yes,
plus 2
sir.
is a factor then. Good. So we get one factor. You can keep trying all of these, you know. You can try minus 1, 1, and so, right? You can try that. Alternatively, you can try them and see if you can figure out another factor, right? Alternatively, you could do the long division now. See if I can make it smaller, maybe. So let's do the long division and see what happens. So we're gonna go with x cubed plus 2x squared minus x minus 2 divided by x plus 2, right? We expect to get 0 at the bottom here somewhere. So x into x cubed, you get x squared, all right? X by x squared, you get x cubed, sorry. 2 by x squared, you get 2x squared. Okay, interesting. So when you subtract here, all of this goes, and you're left with minus x minus 2, okay? Then x into minus x will give you minus 1. X times minus 1, you get minus x. 2 times minus 2, you get minus 2. So when you subtract, you get 0. So indeed, x plus 2 is a factor. So both conform it. The factor theorem conforms it, and the long division conforms it. So basically what we found out so far is that x cubed plus 2x squared minus x minus 2 is equal to x plus 2 times x squared minus 1, right? And you can see that you can quickly factorize this now, right? What will it be? X plus 1, x minus 1, right? So you fully factorize the thing there. Of course, if you had tried minus 1 and 1, both will be equal to 1. So you didn't have to do this, this long division here. Right? Now, instead of this long division, right? Because in this case, let's just say you know, all the factors, trying them in here is too much long work. And you know, this long division is rather scary, isn't it? Or you think it's easy? If it's easy,
Scary.
I'm happy, right? So there's something called synthetic division. The students many years ago, they brought this from the internet and said, sir, they got a shortcut in the on the internet, man, something called synthetic division. So this is how we do synthetic division. We take the coefficients of the function, right? So we lay them out. 1, 2, -1, -2, right? And we are going to divide. I'm going to put it like this here. I'm going to divide it by, what's this? -2 here, right? So you bring down this 1 here. And then you multiply this -2 here by the 1. You put it here. And then you add. You get 0. Okay. Then this by this. You get 0. You add and come down. You get -1. -2 by -1 gives you +2. When you add, you get 0. The fact that you now get 0 at the end there tells you that you have a factor, that x plus 2 is a factor, right? So what are we going to do with all these numbers now? What is this now? What is all of this, right? So what this is telling you now is that when you divide this long x cubed plus 2x squared minus x minus 2 by x plus 2, you're getting here, this here will be the coefficient of x squared, right? This will be the coefficient of, okay, plus x, right? 0, 1, and then -1, right? So when you divide x cubed plus 2x squared minus x minus 2 by x plus 2, you get x squared minus 1. Notice here that this is the coefficient of x cubed. But when you divide by x, what will be left is an x squared term, right? After the x squared term comes the x term, and then comes the constant at the end. So that's why I have here 1x squared plus 0x minus 1, which is simply this. So that's synthetic division. I'll do an example or two more for you. So instead of doing long division, right? Instead of doing long division, you can do synthetic division. Let's do another one. So let us say you're told to factorize. All right, let me go. Factorize x cubed minus 6x squared minus 6. You're told to factorize that, right? So as I said, you got to find one factor first, right? So you can try numbers like, -2, factors of -6, right? -3, -1, 0, 1, 2, 3. You try these numbers, right? Just to find one factor, right? So what I'm going to try 1. That seemed to, well, I just want to try 1, right? F1. Let's see what happens. You get 1 cubed minus 6 times 1 squared plus 11 by 1 minus 6. 1 minus 6. Well, all right. Yeah. 1 minus 6 is how much, buddy? Is that right? Will it give you 0? Think so, right?
Yes, sir.
It'll give you, so x minus 1 is a factor, right? Is a factor. So instead of doing the long division now to find the other factors, we're going to do the synthetic thing, right? So I'm going to go different things on the internet will show you it looking differently, right? Some of them will have this. Okay, take all the coefficients in front here. So you got 1, you got -6, you got 11.
Sir,
Ah.
0 isn't a factor of 6.
Oh, okay, all right. Somebody paying attention. I mean, you can't divide by 0, right? The money, remind me to add one more mark to your thing, you know, man. I'm testing you out to see who is asleep and who is awake. The money is the only man who is paying attention.
I keep looking at that thing like,
I didn't realize myself. Right? I didn't realize myself. I'm half asleep here. Yeah, okay. So we took. Oh my. Somebody's paying attention. All right, yeah. Yeah, so sometimes that happens, eh? You see something not right. You don't know what it is, but you are so distracted unless you can pick out what is going wrong, you can't move on. I'm happy you did that. All right, yeah. Good. All right. So let's go back to our long division here. So you go with, all right, put it like this. Some textbooks will do it differently. So if x minus 1 is a factor, we put 1 here, right? So we bring down this 1, okay? 1 by 1 gives you 1, and you add these two, you get -5. 1 by the -5 gives you -5. You add these two, you get 6. 1 by 6, you give you 6. You add these two, you get 0, right? Again, this is the remainder at the end here. Tells you indeed that x minus 1 is a factor, right? Good. Now that you found x minus 1 is indeed a factor, this is what is remaining now. When you divide x cubed blah 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 by x minus 1, you're getting x squared minus 5x plus 6 as the, what do you call it? The dividend, right? The dividend. What we call it? Quotient, right? Sorry, I think I said it wrong. What am I saying? The quotient is the result. Did I use the word dividend before? The divisor is x minus 1. The dividend is the actual polynomial. And this is the quotient. Nobody can correct me there, man. Use the wrong phrasal in this class. Eh? Right? So this is the
to be
quotient.
honest, it just translated in my head. I don't really use them phrases. All I know is when this there at the bottom, what is there at the top. I should
Okay.
probably learn them phrases because I know to do it, but like to explain it, I probably would use the wrong word.
Okay. Yeah. So we end up with, we know x minus 1 is a factor. When you divide, this here is what we call the dividend, right? And this is the divisor. And this is the quotient now, right? X squared minus 5x plus 6, right? Yeah. So, and I think this can be factorized further, right? I think so. You can watch it, two numbers here. Yeah. X minus, I can go with x minus 2 here, and then x minus 3 here, right? And you fully factorize it there. So you see how the factor theorem is helping you here, right? As a matter of fact, no. It could help you do something even greater than that. Let's say you have to solve an equation like this. Solve x cubed minus 6x squared plus 11x minus 6 equals 0. How do you solve that? Well, you factorize it like you did here, and you end up with x minus 1, x minus 2, x minus 3 equals 0. So this implies that x is equal to 1, 2, or 3, right? I guess I don't have to tell you how I came up with that, right? You put each of the brackets equals 0. It's either x minus 1 equals 0, or x minus 2 equals 0, or x minus 3 equals 0, right? Which implies that x equal 1, or x equal 2, or x equal 3, right? There are the three solutions there. So you can actually now solve not just quadratics, you can actually solve what they'll call a polynomial of power or of order 3, right? Look at that. So your synthetic division can give you the remainder as well. Not every time what you're dividing by is a factor. So whatever you end up with at the end there, you can get a factor, right? I'm sorry, you can get a remainder, right? You're going to get a remainder at the end here. So synthetic division can help you do that quickly. You can use your remainder theorem. You can use synthetic division. You can use long division. It's up to you, right? As a matter of fact, this can help you to plot this graph now. Oh my, look, scatteration here now. We can even plot the graph now. I could tell you, well, here, can you plot this graph? What does this graph look like? Right? So you know, all right, let me just show you something here now. So you know the graph cuts at 1, 2, and 3, right? 1, 2, 3. All right. Let me utilize the so you know that the graph cuts at 1, 2, 3, right? You know the graph cuts there. You also know that the graph passes through -6. So somewhere at the bottom here, -6, the graph comes through, right? So you, without even knowing anything, you can see that the graph comes like this. Watch it. The graph comes through there, goes up somewhere there, comes down back here, comes down back here, and goes up there, right? Well, it got passed through 3, right? The graph looks something like that. An alternative way of knowing where the graph starts, where it ends, is this. The x cubed term, is the dominant term, right? So when x tends to a large number, I use infinity for that, x cubed, and I'm going to use, all right, let me go with negative. When x is a very negative number, x cubed is also a very negative number. When x is a very positive number, positive infinity, x cubed is also a very positive number. So what this is telling you, when x is a very negative number, meaning as you go negative, negative, negative here, x cubed comes from the bottom here somewhere, right? Somewhere at the bottom here. So the graph starts here. But you didn't need to know that because this -6 is going to tell you that the graph starts at the bottom here. And when x tends to a very large positive number now, x cubed tends to a very positive number, right? A very large positive number. So you know the graph end off on top there. So you get an idea of what the graph looks like, right? You don't have to do this analysis, but you can make use of the number at the end here. It can be tricky though. It can be tricky. But very often it can lead you in the right direction. When we do calculus, we're going to find a better way to sketch this graph. But I'm just showing you what is possible because of the factor and remainder theorem. I think all kinds of other types of questions. Let me give you this one. Can I move this now?
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Yes, sir. Please move
All
it far away.
right. You're saying move it? All right. I'll borrow one from the exercise, and it can get more complicated. Here it is. Watch this one. If x squared minus 7x plus a has remainder, I'm just showing you the amount of things they can, type of problems they can give you is quite a bit. So I'm just showing you the kind of twists. Has remained 1 when divided by x plus 1. Find a, right? Find a. So all they're telling you that, you know what, when you divide this expression here by x plus 1, you get a remainder of 1. So in other words, if you were to name this fx, right? F minus 1 is equals to 1, right? In other words, if you were to substitute minus 1 in here, you get minus 1 squared minus 7 times minus 1 plus a. All of this should be equal to 1. That's the remainder. So you get what? 1 plus 7 plus a equal 1. So you get 8 plus a equal 1. A then is equal to minus 7. That's sort of all kinds of variation of the problem you can end up getting. Right? In the little exercise that what do you call it, the tutorial worksheet, you're going to see a lot of variations of the problem. Right? And you're going to try them, knowing the little bit you learn here about the factor and the remainder theorem. Good. So we're going to stop there.
Yes, sir. Please.